and that means you're consuming 10 chocolate bars. Okay, so that's the idea. So you're setting aside resources for the future, and then what's not saved is essentially consumed, and it's consumed by the entire family, and it's consumed evenly. So every chocolate bar is split between all family members. Now when you're old, you're getting a return on your savings. That's the interest rate, and that's what you consume, because you don't leave any bequests. Now, last thing I'm introducing is this thing here. Why? Well, because of the following thing. Please note that saving removes consumption from the family and allows it to consume it on your own when you're old. So it's like you get these 100 chocolate bars, and you're taking a large share of these chocolate bars, put it into the locker box, and then you say to your kids, oh, I don't have very many chocolate bars to share with you. And then, you'll eat very little chocolate bars, and your kids eat very chocolate bars. So you have an incentive to save. I mean, that's a sad argument, just to save it from your kids. Now, to go against this argument, I'm introducing this here, which says consumption when you're young is more fun, because actually consuming with your kids is nice. Okay? I mean, what is the relationship between parents and children? I mean, it's of course you're sharing resources with your children, but it's not just about that they kind of eat the stuff that you earn. I mean, otherwise we wouldn't have children. I mean, we have children because we love spending time with them, right? And so that goes against it. This is why I'm introducing this. Just to say, okay, it's essentially giving more weight to young age consumption, saying, okay, I have an incentive to postpone consumption because I'm saving income from my kids, but also I have an incentive to consume right now and to share with my kids because it's fun. It increase my utility. So that's the thing, right? And the last thing I want to do, and I think these 3 minutes will be enough to write down the optimization problem. I'm maximizing as a person in period t, I'm maximizing this thing, and I have yt minus bt plus 1 o divided by 1 plus mu t to the power of 1 minus sigma minus 1 over 1 minus sigma plus beta 1 plus r bt plus 1 o to the power of 1 minus sigma minus 1 over 1 minus sigma. Okay, so what do economists do when they have nothing else to do? They take a derivative. Now, what is the variable with respect to which we take the derivative? Well, it's bt plus 1o. So we choose the optimal saving to maximize utility. And of course, you see that saving rocks because it increases second period utility, but saving sucks because it reduces current utility. So let me put it on my glasses, and I'll give you I'll need some more 5 minutes, and I'll give them, right, so we take a derivative which says we have 1 plus mu t yt minus bt plus 1 o over 1 plus mu t to the power of minus sigma times minus 1 over 1 plus mu t plus beta 1 plus r bt plus 1 o to the power of minus sigma times 1 plus r, and that should be equal to 0. So that's the first order condition. Now I think blue works better. Let me. Where is blue? It's gone. So this is equivalent to saying beta 1 plus r 1 plus r bt plus 1 o to the power of minus sigma equals yt minus bt plus 1 o over 1 plus mu t to the power of minus sigma. All right. Wait a second. There's yeah, that cancels out. That's the point, right? And the minus 1 doesn't cancel out. Good. Okay, so the blue one doesn't work that well as I hoped. Now, let me do the following. We want to get rid of this. So we turn this into beta 1 plus r to the power of minus 1 over sigma. And then we have 1 plus r bt plus 1 o. And we have yt minus bt plus 1 o to the divided by 1 plus mu t. So now we have a beta here, we have a 1 plus r here, we have a 1 plus r there as well, and we have a 1 plus mu t here. So let me go step by step. We have beta to the power of 1 minus sigma. We have a 1 plus r to the power of 1 over 1 to the power of 1 minus 1 over sigma, and we have a 1 plus mu t here. And that gives us, and the whole thing is multiplied by bt plus 1o. And here we have yt minus bt plus 1o. And finally, and we are on our last meters, promise, we have bt plus 1 o, big fat bracket, 1 plus beta to the power of 1 over sigma, 1 plus r to the power of 1 minus 1 over sigma, 1 plus mu t equals yt. Now, last thing, note that this can be written as sigma minus 1 over sigma. Wow, that's well, I remember attending a class by Kenneth Rogoff, and he kept, deriving things, and he always said it's just algebra. Maybe, yeah, he was right, of course, but it was, yeah. Anyway, now this is the result. Last thing you have to do is you have to divide both sides by this thing, and then you get bt plus 1 equals yt, and then you have in the denominator, you have 1 plus mu t, beta to the power of minus 1 over sigma, 1 plus mu t, and this thing. Okay? And that's it. Now let's have a break, and I'll see you again at 1:15, and then we'll tackle the third problem set. Now, but that's that's a super cool result. I mean, this is really something we'll dwell on Monday, because we'll learn a lot from this. Not just about overlapping generations models, but about, for example, savings behavior and the interest rate. And please, if you want to, if you have some time to spare on the weekend, stare at that for 15 minutes and realize that the effect of the interest rate on BT plus 1 is not unambiguous, but I don't want to spill the beans. Good. All right. So I'm closing the presentation. I'm closing this thing as well. I'm closing that thing as well. And I'm driving on. So have some food and take a rest, and then in an hour I'll be back. And here's the